What's up, gamers? It's Miss Sorensen again, back with video 3. I can't wait. I hope you can't either. Let's get started. Normal distribution. Here we go. The bell curve, which represents a normal distribution of data, shows what standard deviation represents. So we just spent a whole video on standard deviation, and we should realize that if it is a perfect bell curve or normal distribution, then we should have our average right here in the middle. All right, and then we also have 1S, or one standard deviation, meaning that 34.1% of the population should fall within one standard deviation to the right of the mean. All right, what else? Well, we can go ahead and continue filling in this chart. 2 standard deviations, 3 standard deviation, minus 1 standard deviation, minus 2 standard deviation, minus 3. And so if we look at this chart right here, and I'm talking about this group of people right here, if we add up 34.1 and 13.6, so let me do that now. If I add up 34.1 and 13.6, that gives me 47.7, and that means percent, meaning that if we have a normal distribution, which I'm saying we do, then 47.7% of the population would be within 2 standard deviations to the right of the mean. Okay, so for example, let's say our average on a test score was a 75. Okay, and our standard deviation was, say, 3 points. If we add a standard deviation, this would actually be a test score. Let's actually erase the whole thing here. This would be a test score of 75. Adding 3 points to that, we would get 78%. And here, we would actually have 81%. So that means that we would have 47.7% of the population would be within the range of 75 to 81. And we're going to do a little bit more math with that later, okay? All right, let's go back and look at what this text is saying on the bottom here. This is saying that roughly, okay, if you'd like to use these exact decimal values, you are totally welcome to. If not, if you want to use just the 68%, 95%, and 99.7%, you're welcome to. All right, one standard deviation away from the mean in either direction on the horizontal axis accounts for around 68%. What am I talking about there? I'm talking about, here's my X bar, excuse me. Here's my X bar, here's one standard deviation, here's one standard deviation. And we're actually talking about both directions here, right? It says one standard deviation away from the mean in either direction. So that is this value right here. Now add up 34% and 34% and you get roughly 68%. Technically 68.2. Like I said, you can use 68 or 68.2. It's up to you. Now, what about being 2 standard deviations away from the mean? Well, let's add those to our chart here. So this would be 2 standard deviations, a 2 standard deviation. I'll just put this in here for now. So if we're talking about being 2 standard deviations away from the mean in either direction, we're talking about this right here that I'm highlighting. And if you add up all those values, you're going to get roughly 95%. Now lastly, if we're talking about 3 standard deviations away from the mean, that's going to be 99.7% of the data, which is pretty much everyone. Okay, here we go. All right, and so that's, you can use 99.7, 99.8, whatever works for you. I'm not going to be super picky about that. Normal distribution curve. If you have a normal curve, then the mean and the median and the mode should all be right here. There'll be symmetry about the center, and we would see that since that's the median, 50% of the values would be on the left and 50% of the values would be on the right. And this actually represents quite a few real-world situations. Here's kind of a summary from 2 slides ago. We're saying that 68% of the values are within 1 standard deviation of the mean, meaning if you're talking about test scores, you could say something like 68% of people scored between this score and that score. And then similarly, we're widening our spread here and saying 95% of values are within 2 standard deviations of the mean. And then 99.7 or 99.8, whichever you prefer, of the values are within 3 standard deviations of the mean. And really, 3 standard deviations of the mean is a huge spread. That's like saying test scores from 60 to 90. And that's why we can say with much confidence that 99.7% of the values are within that range. And so what we're really trying to summarize here is what is standard deviation, and this is a hugely important summary. That standard deviation is the measure of how spread out the numbers are. Okay, so that is very important for understanding the next problems. Why do we need to know standard deviation? Well, it helps us figure out how likely it is to be within 1 standard deviation of the mean. It tells us that we are very likely to be within 2 standard deviations of the mean, and we can say with 99.7% certainty that we're within 3 standard deviations of the mean. So let's actually do a problem. I think this is going to really help you put everything together. So assuming that this data is normally distributed, can you calculate the mean and the standard deviation? Well, we have that 95% of students at school are between 1.1 meters and 1.7 meters tall. So in this situation, if we're talking about 95%, notice here that we're actually talking about being -2 to 2 standard deviations away from the mean. And I realized that because the 95% alerted me to the -2 to 2. So if we're between 1.1 meters and 1.7, here's my average right here. I'm going to go to the left twice, and I'm going to say that this is going to be 1.1 meters, or I can just write 1.1. And then here, two standard deviations, I'm going to be at 1.7. Why do I know that? Because they told me 95% were in that range. Well, can we find our average from 1.1 and 1.7? Certainly. Right, we're just going to add up 1.1 plus 1.7. We're going to divide that by 2, and that's going to give us 1.4. So now we know that our average of our sample is 1.4 meters. All right, so I've already done the mean. Now let's go ahead and find the standard deviation. And to do that, I need to fill in the rest of my curve. Well, how do I get this value right here? Well, clearly it comes from an average between these two right here. So let's do that. Let's do 1.4 plus 1.7 divided by 2. And that gives me 1.55. So this value right here is 1.55. Now, I could certainly find the average between these two here, but it's not necessary, but I think it's kind of nice to know that this would be a 1.25. We would do the same thing averaging those two values. But what the question is really asking is, what's the standard deviation? And to do that, we know to get from our x bar to our 1 standard deviation away, we jump a standard deviation. So all I have to do is 1.55 minus 1.4, and that gives me 0.15. And 0.15 is my S, or if you want to write SD for standard deviation, of 0.15. Have we got what we needed? We've got our X bar and our standard deviation. I do want to check this. So is it a 0.15 jump here? Yes. How about 1.55 plus 0.15? Is that a 0.15 jump? Yes, it is. Do I subtract 0.15 and get here? Yes, I do. Can I subtract 0.15 and get here? Yes, I do. So it looks like my answer is correct. All right, here we go. We've got another problem here. It says 68% of Americans own a dog, and it's between 4 and 6 years old. So what is the standard deviation? Well, let's go down to this picture right here. It says 68%, so we're really saying that it's between 4 and 6. Well, what's the average between the two there? 4 plus 6 is 10, divided by 2 is 5, or you can clearly see it's 5. So what is our X bar, or our average? It is going to be 5. What's our S, or if you want to write standard deviation, SD? Well, what's the jump from 5 to 6? Or, how are we going from, what are we subtracting to get from 5 to 4? Well, clearly that's a standard deviation of 1, because we're going from 5 to 6. That's plus 1. We're going from 5 to 4. That's minus 1. That's all it asked us for, and we're done with that problem. All right, next question. Getting a little bit harder. The next question says, the reaction times for a hand-eye coordination test administered to 1,800 teenagers are normally distributed with a mean of 0.35 and a standard deviation of 0.05. They'd like me to represent this information on the bell curve. Let's do it. So if I have a mean, or an X bar, of 0.35, I'm going to go ahead and put that right in the middle. And if my standard deviation is 0.05, I'm going to go ahead and I'm going to add 0.05, and then add 0.05 again, and then add 0.05 again. So let's see what that gives us. See, adding 0.05, we get 0.4, and then add it again, 0.45, add it one more time, 0.5. Okay, now, how do I get to the left? Well, we are subtracting a standard deviation. So this is going to give me a 0.3, a 0.25, and a 0.2. All right. Next thing we need to do is we need to answer our questions, and to do so, it's really helpful to use this. You will not have to memorize this. You can use this on a test or a quiz. So it says, about how many teens had a reaction time between 0.25 and 0.45? Well, let's look at what we're looking at here. We're looking at from here to here. What is that represented? That's going to be from 2 standard deviations to the left. So from here to 2 standard deviations to the right. If I add up all of these percents right here, from 2 standard deviations to the left to 2 standard deviations to the right, because I'm just dealing with this value right here, I'm getting 95.4%, meaning 95.4% are within this range right here. And we know that because we're saying it's normally distributed. So how many teens had that reaction? Well, 1,800 people were tested. So I'm going to have 1,800. I'm going to multiply that by my 0.954. You always want to convert your percentages into a decimal. And that gives me roughly 171,720 teens. Okay. All right, next question says, what's the probability that a teenager selected at random had a reaction greater than 0.4 seconds? Well, we need to relook at this graph up here. Okay, greater than 0.4 seconds. We are talking about from here over. And so if I go back over here, I'm looking for being 1 standard deviation away, right here, all the way to the right. So I'm looking for it to add up those right there. And I do that, I add up 13.6 plus 2.1 plus 0.1, and I get roughly 15.81%. However, this question's actually asking me for a probability. Well, if I'm talking about percent, that's actually out of 100. So for probability, I could write this is 15.81%, if you will. And what is that percent out of 100%? So I could say 15.81 out of 100. That's a probability when we write it as a fraction. And I'm going to go ahead and multiply by 100, moving the decimal over twice. So that's going to give me 1581. And then I'm going to multiply this by 100, right? Because I've moved the decimal twice. So this is going to be, or you could just think of it as adding 2 zeros, if you will. And so that leaves me with 1581 over 10,000 is my probability. I tried to reduce that on my calculator. It's not reducible, so we can leave it just like that. All right, second to last problem here. The waiting times for an elevator are normally distributed with a mean of 1.5 minutes and a standard deviation of 20 seconds. Let's go ahead and let's mark the picture. So we've got 1.5 minutes as our average. But let's go ahead and convert that into seconds. That's going to be 60 seconds plus 30 seconds is going to be 90. And then we've got a standard deviation of 20 seconds. So I'm going to add 20. So that gives me 110. I'm going to add 20 again. That's going to give me 130. Add 20 again. That's going to give me 150. Now I need to go ahead and subtract 20 in the other direction. So that's going to be 70. This is going to be 50. And this is going to be 30. All right. Final question here says, find the probability that a person waits longer than 2 minutes and 10 seconds for the elevator. Well, gosh darn it, we've got to convert that into seconds. So 2 minutes is 120 seconds, plus another 10 seconds equals 130. All right, well, where are we at the 130? Let me highlight this here. So 130, we're talking about this right here. And so that's going to be my 2 standard deviations away from the mean. So we're talking about this 2.1% and that 0.1%. So that is going to actually be a 2.1 plus a 0.1 gives me 2.2%. However, it asked me for probability. So I'm going to say that this is actually 2.2 out of 100. That's how percents work. I'm going to multiply both of these by 10 or move the decimal 1 and add a 0. So that's going to give me 22 over 100. Then go ahead and use your graphing calculator, math bracket, or just divide both by 2, and we're left with a probability of 11 people out of 50 will have that range of waiting to, excuse me, oh, sorry about that. I should be adding 1 more 0 right here, right? Because there was just 2 zeros here. So this should be 11 out of 500, which makes a lot more sense, right? Because we don't have that many people in that range. All right. Last question here. Mrs. Smith gave a test in her Algebra 2 class. The scores were normally distributed with a mean of 85. Let's plop that in there. And a standard deviation of 3. So adding 3, 88. Adding 3, 91. Adding 3 again, 94. Subtract 3, we're at 82. Subtract 3, we're at 79. Subtract 3, we are at 76. What percent would you expect to score between 82 and 88? Okay, well, we need our handy-dandy normal distribution curve. And take my highlighter here, and I'm talking about between 82 and 88. Okay, I should have drawn a bar here. So between 82 and 88, that's clearly one standard deviation this way and one standard deviation that way. And so we're dealing with just these values right here. Add up those two, and we're left with a 68.2%. Thanks so much for listening. Looking forward to our next video. Make sure you complete the assignment with this video. Thanks so much. Have a great one.